An intriguing theory circulates, suggesting that chickens may be descendants of the fearsome Tyrannosaurus rex. This speculation leads us to explore the surprising connections between these gigantic monsters that roamed the Earth millions of years ago and the birds we know today. While scientists assert that birds coexisted with dinosaurs, the question remains, how did birds manage to survive until today while dinosaurs were wiped out by an asteroid impact? And what similarities might exist between these species? Birds belong to one of the three major groups of dinosaurs, the Theropods, forming a basal branch within the grouping called Coelurosauria. Some famous members of this group include the Velociraptor, a close relative to birds, and the Tyrannosaurus rex, a more distant relative. Many members of this clade sported feathers or feather precursors, likely for thermal regulation. Thus, birds were not pioneers in the realm of feathers. Over more than 80 million years, a variety of birds thrived, ranging from those resembling toothed swimmers to those with elaborate feathers soaring across the skies. About 66 million years ago, a colossal asteroid collided with what is now the Yucatan Peninsula, triggering the fifth mass extinction in Earth's history. The ejected debris returned to the atmosphere, sparking global fires upon re-entry. This impact generated intense heat, followed by an extended period of winter as dust and ash obscured the sky and temperatures dropped. In the end, over 75% of known species from the late Cretaceous period were annihilated. The geological boundary between these periods is known as the Cretaceous-Paleogene boundary, and beaked birds survived as the only dinosaurs to withstand the catastrophe. However, evolution had set its course long before the asteroid's fall, which led to the development of beaks. The evolutionary journey of birds began with teeth, as evidenced by Archaeopteryx, the first bird, 150 million years ago. Yet, for tens of millions of years after this bird, toothed birds thrived alongside their dinosaur relatives. However, over time, some birds lost their teeth, replacing them with beaks adapted for grasping and selecting food. This transformation might seem counterintuitive in terms of evolution, considering the advantages of teeth. Many scholars have delved into unraveling this metamorphosis, initially suggesting a relationship with flight. However, with the discovery of flying-toothed birds, it was proposed that feeding played a significant role, driving birds to evolve beaks devoid of teeth. During the time ancient birds thrived alongside other dinosaurs, a correlation emerged between groups of dinosaurs that lost their teeth and acquired beaks as they became herbivores. While early birds used teeth to capture insects, some lineages specialized in plant-based diets. Thus, the development of the beak might have played a crucial role. As it evolved, changes in the skull may have altered embryonic interactions, leading to tooth loss. Birds faced the catastrophe with evolutionary attributes honed over millions of years, becoming the dividing line between survival and extinction. However, not all birds survived. It's important to remember that only a fraction of diversity managed to withstand, pointing to an element of luck in the process. An essential element was the dietary variety of birds. Those with beaks devoid of teeth were able to feed on hard foods like seeds, providing a vital advantage during the tough times after the extinction. The complexity of survival reveals that it wasn't a single trait, but a combination of factors that allowed certain species to persist. However, the evolutionary journey often carries limitations. The loss of teeth limited the dietary niches explored by birds, while herbivorous mammals and dinosaurs developed teeth with continuous growth to counter wear. The adaptation of the beak proved more advantageous in this scenario. The presence of bird species related to ducks, parrots, and chickens at the time of the impact was crucial in initiating the rebuilding of bird populations after the extinction. While some birds suffered losses, it marked the beginning of a new evolutionary era in which size decreased, but intelligence advanced. However, evolutionary changes are not free from limitations. Tooth loss brought stability but also restricted diversification. The ongoing search for fossils and evidence leads us to seek information in the years following the extinction, a period called the Paleocene. Although specimens from the Eocene period, about 10 million years after the extinction, are known, the links between the Cretaceous and the Eocene remain fragmented and elusive. It's in this layer that we hope to uncover ancestral secrets waiting to be unveiled. The journey through time reveals astonishing connections between the birds populating our world today and the fearsome dinosaurs of the distant past. Understanding how these creatures evolved and faced cosmic challenges is a fascinating adventure that allows us to unlock the secrets of survival. Now, it's time to dive deeper into this intriguing story. Subscribe to the channel to not miss any future episodes, and continue exploring the incredible world of evolution and life on our planet. As we unravel this incredible narrative, let's remember that each bird soaring through our skies carries with it the epic story of a lineage that resisted and triumphed. And thus, we continue our relentless quest for knowledge, exploring the mysteries awaiting revelation in the deep layers of the Earth. Now, if you want to learn more about innovative new technologies that are changing the way we live, check out the video that's appearing on your screen now. See you next time.